Good day everyone. In today's video, we were going to talk about the second part of our lesson about differential equation, which is the homogeneous function. So, building upon the foundational tool of separation of variables, we now extend our analytical toolkit to a broader class of problems, which is the homogeneous first order differential equation. So, while not immediately separable in their standard form, this equation possess a distinct structural symmetry that allows them to be transformed into a separable format through a specific substitution. So this is useful in order for us to separate the equation. So this lesson will guide us in recognizing the defining characteristic of homogeneous equation and mastering the technique of strategically introducing a new variable to unlock for the solution. Also, at the end of this discussion, we will going to acquire or define homogeneous equation and apply the appropriate substitution to transform homogeneous into separable equation. And also, we are going to solve the resulting separable equation and substitute back to express the general solution. First, let's define what is homogeneous equation. So, a differential equation of the form f of xy dy is equals to g of xy dx is said to be homogeneous differential equation if the degree of f of xy and g of xy is same equation. For instance, m dx plus n dy is equals to 0. So to solve this, let y is equals to vx and the dy is equals to v dx plus x dv, or x is equals to vy and the dx is equals to v dy plus y dv. So this substitution will lead to variable separable. Now let's have our first example. We have here solve the differential equation 3 times x squared plus y squared times dx minus 2xy dy is equals to 0. So the first thing that we were going to do is to write the given, and then we let y is equals to vx and the dy is equals to v dx plus x dv and integrate it. So why does we choose y and dy? Because it is the simpler part rather than the dx, as we can see at the given, so that we choose the y. So now that we let y and dy, we substitute now the value. So now we have 3 times x squared plus substitute vy squared times dx minus 2x times vx, substitute again v dx plus x dv is equals to 0. Now we operate the operation 3 times 3 plus v squared times x squared dx minus 2v x squared times v dx plus x dv is equals to 0. Next is x squared times 3 plus v squared times dx minus 2v times v dx plus x dv over x squared is equals to 0 over x squared, so that we can eliminate the x squared. So now we have 3 times 3 plus v squared dx minus 2v times v dx plus x dv is equals to 0. Now we operate the operation 9dx plus 3v squared dx minus 2v squared dx minus 2vx dv is equals to 0. Next is we combine like terms. So we have now 9dx plus v squared dx minus 2vx dv is equals to 0. Simplify it. We have 9 plus v squared dx minus 2vx dv is equals to 0. So now to eliminate to remain the dx and x and separate it to v, we divide both sides by x times 9 plus v squared, so that the remaining part is dx over x minus 2v dv over 9 plus v squared is equals to 0. Now that we've separate the x and the v, we can now integrate. So we have the integral of dx over x minus integral of 2v dv over 9 plus v squared is equals to 0. So the integral of dx over x is ln x, and the integral of 2v dv over 9 plus v squared is ln 9 plus v squared is equals to ln c. So simplify it. ln x over 9 plus v squared is equals to ln c. X over 9 plus v squared is equals to c. So we have x equals to c times 9 plus v squared. So we have an answer of x cubed over c9x squared plus y squared. Now for our second example, we have solved the equation x squared minus y squared dx plus 2xy dy is equals to 0. So same with earlier, we look for the simpler part. So the simpler part of this is the dy. That's why we let y is equals to vx and dy is equals to v dx plus x dv. So now we substitute it. We have x squared minus vx squared dx plus 2x times vx times v dx plus x dv is equals to 0. Next is we have x squared times 1 minus v squared dx plus 2vx squared times v dx plus x dv is equals to 0. Now to eliminate the x squared, we divide it. Now after dividing, we have 1 minus v squared dx plus 2v v dx plus x dv is equals to 0. So simplify by substituting. So we have 1 minus v squared dx plus 2v squared dx plus 2vx dv is equals to 0. Now combine the like terms. So we have 1 minus v squared plus 2v squared times dx plus 2vx dv is equals to 0. So we have now, by simplifying, 1 plus v squared dx plus 2vx dv is equals to 0. Now we equate the 2vx dv and it becomes negative 2vx dv. So to separate it, we divide both sides by x times 1 plus v squared. So the remaining, we have dx over x is equals to negative 2v dv over 1 plus v squared. Now we can integrate it because we already separate the x and the v. So we have integral of dx over x is equals to the integral of negative 2v dv over 1 plus v squared. So the integral is ln x is equals to negative ln 1 plus v squared plus c ln x plus ln 1 plus v squared is equals to c sub 1. So we equate it so that we can combine, and we have ln of x times 1 plus v squared is equals to c sub 1. X 1 plus v squared is equals to c sub 1. So from y equals to vx, we can have v is equals to y over x. So we substitute it. Now we have x 1 plus y squared over x squared equals to c. X plus y squared over x is equals to c. And the final answer is x squared plus y squared is equals to c sub x. And that's all. Thank you.